recording now, so
Okay.
I don't know how this is going to turn out, but I think it's going to be okay.
Yeah. So the distance between the two tips, that's 15 centimeters, and the cross section is about 1 square centimeter. So you end up with 15 cubic centimeters that one laser pulse can see. And that is the specialty of HOLODEC, that the image that you get here, you can actually reconstruct with a computer to see where each droplet that is in this whole sample volume was. Other instruments, they just sample one droplet at a time, but with HOLODEC you can actually get a reasonable size distribution by looking at just one image. So that's the good thing about HOLODEC. But what can you actually see? So this is an example of an ice crystal that was measured 2 years ago with HOLODEC, and it's 1.1 millimeter across, and it looks very pretty, but that's good luck, because sometimes they also get shattered. We try to minimize that by using the special design of the sharp tips, but as you can see, sometimes it still happens. But because in HOLODEC you can actually see that all the parts of the shattered ice crystals are close together, you can actually identify shattered ice crystals. So these examples, what you can see is not what I start off with. So the original image that the camera records looks like this. You can see that the laser beam is brighter in the middle and it's darker at the edge. So the laser beam itself has some impurities, and the interference patterns that you see, all those rings, they are mainly impurities on the lenses and so on. Only this one, that is actually a droplet, but that you can only know because I've already looked at that image and I will show you how that looks like. So if you look at the same image zoomed in the software that I'm using for analysis, so this droplet is now zoomed in, and the contrast and brightness have changed a little. What you do is first you actually filter out the background. That is done by looking at consecutive images, and the background is in each image, so you can actually identify the background. Now you can see that it looks much more clear, and all those interference rings that you can see now, they are actually droplets. So this is how the image would look like, right, what the camera sees. But now the software can actually go through the whole volume and focus in on different distances from the camera. So that I just show you how it will look like for this droplet, and you can see that it takes some time to actually compute that, and that is the part of HOLODEC that takes long, the reconstruction. So this was just one slice difference. This is the droplet now in focus, and I saw that it's 150 microns in diameter, and this small one here, you can zoom on this, that is a cloud droplet with 20 microns diameter, and the other rings that are in there, they're cloud particles that are out of focus. They are at a different distance from the camera.
Okay, well, that looks good. So let me ask you a question though. So what in CSET? What are you going to be doing with HOLODEC?
So that image that I showed, that is actually already from CSET data, and you can also do some size distributions. Can we stop?
Sure.